So this is a question from GATE 2025. And the question is, in the circuit, IDC is an ideal current source. The transistors M1 and M2 are assumed to be biased in saturation, wherein Vin is the input signal and VDC is a fixed DC voltage. Both the transistors have a small signal resistance of RDS and transconductance of GM. So both these transistors M1 and M2 has the same resistance, output resistance RDS, and the transconductance GM. Okay, the small signal output impedance of the circuit. So we need to find the small signal output impedance. So for that, what we need to do is we need to draw the small signal equivalent circuit of the circuit. Okay, so for drawing the small signal equivalent, what we have to do, we should first remove the DC voltage and DC current, right? So DC voltage, here it is VDC, that I have to connect to ground. So this I will connect to ground. VDD I need to connect to ground. And what about the current source? The current source need to be open circuited, right? So if I draw the circuit here, will be M2, M1. So this is open. This is grounded, and here I have the small signal voltage, input voltage V in, and this is grounded, and this is V out, right? Okay, so we will draw the small signal equivalent circuit of this. So we have to draw the small signal equivalent of M1 and M2. So first I will draw the M1. Okay, so this is the gate terminal of M1, this is the drain terminal, this is the source terminal of M1, and this is the output resistance RDS. Okay, so let this be the VGS1. Okay, and the GM is same, right? So GM, VGS1 is this current source, and this is the gate. Okay, so let this be G1, D1S1. So here at gate we have the input signal Vin, right? So similarly I will draw that of the small signal equivalent of the M2. RDS. So this is gate 2, drain 2, and this is source 2. So yeah, so here if you see, the source is connected to the drain of M1. So drain of M1 is this, and this is source S2, right? So I connected this. Gate is connected to ground, right? So gate G2 is connected to ground, and this is VGS2, and the drain is the output, right? At drain we have the output V out. Fine. So now the question is to find the output resistance. So how to find the output resistance? To find output resistance here, what we'll do, we'll apply a voltage source here, okay, Vs, and if this is the current Is, we will find the output resistance, say Z0 equal to Vs by Is, right? So for that, what we have to do, we should connect this Vn, or we should remove this Vn, we should connect this to ground. Fine. So here what we'll do, we'll connect, we'll remove this Vn, or we'll short circuit this, which means Vn is equal to 0. And in the circuit, VGS1 is same as Vn, right? So this is equal to 0. So VGS1 is 0, which means this current is actually 0. This current is 0 means this is like open circuit. Okay. And one more thing, we just forgot to draw this source, right? This should be grounded. Okay. So and here at drain we'll apply the voltage source, fixed voltage source Vs, and find the Vs by Is. Okay. So let us redraw the circuit. So since VGS1 or Vn is 0, this I can open circuit. This source I can open circuit. Okay. So I'll just redraw the circuit. So let me draw first this portion. So D2, gate 2 is grounded, VGS2, this source S2, and at the drain I have applied one voltage source Vs. Okay, so let it be a source signal Vs, and this is Is. Okay, and from this source I have connected to RDS, and this is open circuit. Okay, I mean this current source is open circuit, while this RDS is connected to ground. So I have a resistance like this RDS. Fine. Now if we carefully see here, this VGS2 is actually the voltage across this RDS. How it will be? Here it is minus and here it is plus. So this is actually VGS2. Okay, so I can instead of this I can remove this, right? So it will be like this. Now the circuit will be like this. Okay. Okay, and this VGS2 is here. Now if you carefully see, we have the current Is flowing here. It is split here as GM VGS2, and there is some current flowing through RDS, and again the same current is flowing through RDS. So this is Is. Okay, so from here it is clear that VGS2 is equal to, so since current is flowing from top to bottom, the voltage drop will be plus minus, right? So VGS2 I can write as RDS into Is. Okay, now let us apply the KCL here at this node. So if I apply the KCL here, what the input current is Is, and that is equal to GM VGS2 plus the current through RDS. So what is the current through RDS? The voltage across the RDS, that is this node voltage minus this node voltage by RDS. So this node voltage is actually Vs, right? So Vs minus, what is this node voltage? That is minus Gm VGS2. Right, so minus not Gm VGS2, minus VGS2. So minus VGS2 by the resistance RDS. So that is the current. Now let us substitute. So this is actually minus RDS into Is, right? Yeah. So let us substitute this voltage in this equation. So Gm into VGS2 is minus RDS into Is plus Vs minus VGS2 is minus RDS Is. So I can write as Is RDS, because this minus and minus cancel off by RDS. Okay, so let us take LCM. So minus Gm RDS square Is plus Vs minus Is RDS by RDS is equal to Is. So taking this RDS to LHS, Is into RDS equal to minus Gm RDS square Is plus Vs minus Is RDS. Now I'll bring this to all Is terms into LHS. So I'll have Is into Is RDS plus Is RDS is actually 2 Is RDS, 2 RDS plus Gm RDS square equal to Vs. So what is Vs by Is? Vs by Is is actually 2 RDS plus Gm RDS square. Okay, so the answer is C. Yeah, so this again question from GATE 2025. The question is, the op amps in the following circuit are ideal. The voltage gain of the circuit is dash. Okay, so here there are two op amps, OA1 and OA2, and all resistance are equal to 10 kilo ohm, and Vin is the voltage difference between these two nodes, this node and this node. Okay, so how to solve this? What I will do, I will say there is a source here V1 and say there is a source here V2. Okay, so from here, what is Vin? Vin is equal to this node voltage minus this node. So Vin equal to V2 minus V1. So it will be easy for us to solve. Okay, so if this voltage is V1, okay, if you see here, this is actually non-inverting amplifier, right? With the input voltage V1. So what is this voltage? So I'll call this as V01. So V01 here is the non-inverting gain, that is 1 plus RF by R1. Both are 10, right? So 10K by 10K into the input voltage, that is V1. So 1 plus 1 into V1, that is 2V1 is the output voltage V01. Okay, so this is the output voltage of OA1. Now we'll see what happens at the output of OA2. So here, if I draw, the circuit is like this. Okay, here V2 and here it is V out, and this is VO1 is 10K, 10K. Okay, so what is V out here now? So V out is actually a function of these two voltages, right? So what we'll do, we can apply the superposition theorem. So what is the voltage due to output voltage due to V01, V02? So when V02 is applied, we'll consider this V01 to be grounded. So the output voltage V out due to V2 will be equal to V2 into 1 plus 10K by 10K, that is the non-inverting configuration, right? Okay, plus the next is the voltage, output voltage V out due to V01. So at that case, we will ground V2. So what happens? This is like an inverting configuration, right? So V01 into minus RF by R1. So both are same. So minus 10K by 10K. That is a gain, right? So here V2 into 1 plus 10 plus 10K by 10K is 1 plus 1, that is 2. Plus here it is minus V01, that 10K by 10K. So 2V2 minus, what is V01? V01 here is 2V1, right? So I can apply that value. So it is 2V1. So I'll take 2 outside. It is 2V2 minus V1. Okay. So what is V2 minus V1? That was actually V in, right? So 2 into V in, that is V out. So the question is to find the gain, that is V out by V in. So what is V out by V in? That is equal to 2. So gain is of the circuit is